Hello, Math 126 fans. Somebody on the discussion board is asking me, what polar graphs do I have to graph in the final? I suspect this is coming from one of the recent old finals, had a part where you had to know something was a cardioid or deal with it. So what I thought I would do is what I would do if I was a student. Again, I don't write the final myself. And for the midterm, I said I would give a graph if it was a cardioid, but for the final, you have a little more time. So yes, you may have to graph a little bit, but let me show you what I would do if I was a student. So first I would look at the homework. In the homework, these were 3 of the graphs you had to graph. I think this one came up quite a bit, in not only in 10.3, but also in 15.3. So let's say you're stuck on a test, you have no idea what it looks like, then you use my advice. The first things you would plot are 0, pi over 2, pi, 3 pi over 2. And again, in just a moment, we'll look through old finals to see how this goes. But let's say we're doing this one. You would plug those in. This is where maybe your unit circle would be helpful if you don't know these values. You'd have -9, and you would have 0. But you should already have a sense that this is going to be a circle because we saw it several times. A circle, but a circle that's not centered at the origin. So when you're looking this way, you get 9. When you're looking up, you get 0, which means you hit the origin. When you're looking to the left, you get -9, so you're back here, and then you're like, oh yeah, circle. So I guess if I was going to put something on my note sheet, I would say, all right, we've seen this quite a few times. This is a circle. It's just not centered at the origin. Similarly, we have if r equals a times sine, it's also a circle. It's shifted up. So I guess we'll add that to our library. If we're worried, this is what we'd say. We would say, okay, something that looks like this with a number here is a circle. Something that looks like this with a number here is a circle. It's just not centered at the origin. But for most problems, you wouldn't even need to know that. You might just need to plot a few points. Okay, so circles not necessarily centered at the origin. If it's a circle centered at the origin, then r is just a constant. Okay, so we have a circle not centered at the origin. Another circle not centered at the origin is actually what this is. And then you have the circles that are centered at the origin. Let's say a circle of radius 3 is just r equals 3. So there's a small library that encapsulates, when I looked at old finals, a huge number of old finals are just these. Okay. So let's talk about these other ones. So this one we should have an inkling is the cardioid. In particular, you know, the biggest and smallest this can be is -1 to 1. That also was thinking this back here. And so the smallest is going to be a 0, and that's going to be at pi. So again, if I plotted the first few values, 0, pi over 2, pi, 3 pi over 2. And I would love to say more about this, but right now we're gearing up for the final. So this is going to be 18. This is going to be 9. This is going to be 0. And that's kind of the telltale sign of the cardioid, because the way it works is you're getting a big number over here, and then it gets smaller and smaller. You get 9 here, and then as it swirls around, you get 0 here for an instant, and then it goes back out. I did a really bad job of trying. Anyways, it's a heart shape. So I guess we could add that to our, anything that looks like 1 plus cosine or 1 plus sine, cardioid. But I would think that we would have a little bit of a feeling for that, somewhat just because it came up 2 or 3 times in the homework. Okay. Lastly, we had these things that we called roses. Now, the problem would probably say it's a rose. We saw something like this in the homework. And mostly what you need to do is find when this is 0, because that's when a loop ends. So in such a situation, you would probably start. You could also plot those values I just talked about, but you would start when is this 0. So you would then say when is 4 theta equal to ... And you would list all the places where cosine is 0, pi over 2, and then you would divide -pi over 8, pi over 8. So this is, again, just based off of the homework you've been doing. That was the game. So I didn't see anything else in the homework that we did. So we saw cardioids, circles of various types, and roses. Okay, so now let's look at the old exams and see if I was lying to you. So that gives us a little library from the homework, from our discussion. Let's just get rid of that for a moment. And I'm going to pull up an old exam question. I think this is the one that, and I'm going to look at several. But the one that I got the most questions on today, which I think is where this question is stemming from, because it's the most recent exam in the archive and kind of makes people nervous when they see something like this in a recent exam. So let's talk about it. The question says, find the volume between these two surfaces. And so we know right away that we're step one, find your z's. Okay, so we're finding the volume between this and this. It even tells you the order. It says it's below the cone and above this. And I'd love to make some visuals to show you this, but again, I need to get on to the other questions in the discussion board. Okay, there's a hint to convert to polar. Based off of that hint, I feel like I want to convert right away. X squared plus y squared is r. And z is x squared plus y squared, so there's an r squared. Let me write that in 2 steps so you know what I'm doing. X squared plus y squared minus x, which is r squared minus r cosine of theta. So our next job is to draw the region. That doesn't change when you're doing a polar question. But in order to draw the region, I need to know when these two things intersect. And based off of the hint, that's why I think made this hard, is I want the intersection of those two. So I want to know when r is equal to r squared minus r cosine of theta. I realize I can divide everything by r, and so I get 1 is equal to r minus cosine of theta, and I get r is equal to 1 plus cosine of theta. And I think that is what was scaring students when we did our review of what do I do? So that's the cardioid. I would just plot a few points. When you plug in 0, you get 2. When you plug in pi over 2, you get 1. When you plug in pi, you get 0. And when you plug in 3 pi over 2, so it's this shape. So we're integrating above this shape. Now, a comment about this question, there's no other restriction. So everything is happening above there. And so even if you couldn't draw the picture, when you have a question that's sort of an unrestricted polar question that wants you to integrate over the whole region, I would plot a couple points. So theta equals 0, theta equals 2 pi. And I would say, I just want to go all the way around and touch every single point here. So I would like to do the integral from 0 to 2 pi. And the integral from 0 to the edge of the cardioid. So you didn't actually need to see the picture. But anyways, r times r d theta. That's what this will be, r times r d theta. And then you'll subtract the integral from 0 to 2 pi, the integral from 0 to 1 plus cosine of theta, r squared minus r cosine of theta, r d theta. So the hardest part of that was just sort of not being scared by this. But yes, that's probably one of the toughest graphing polar questions of the last several years. But now you've seen it was one of the ones we talked about. Okay, let's look at a whole bunch more. I think this, like I said, you can do this very quickly. Just pull up exam one after another and scroll through and look at polar questions. And that's exactly what I did. So find the volume of the region that's between, I actually did this during the review. At some point you have to find the intersection of these two things. So you get plus 4x squared plus y squared equals 25. This is the one that my student from a previous quarter made a super cool visual for. Check that out. It's just a circle of radius square root of 5. So that one, hopefully we just know, is r equals square root of 5, and you're integrating from 0 to 2 pi. So in a sense, this is kind of like the question we just did. It's just in the last one we had to go all the way around, but not go out to square root of 5 out to the edge of the cardioid. Let's keep going. So here we have another one that says, let me get this other stuff out of the way. This is from the fall 23. It's a center of mass question. It says first quadrant that's inside this circle and outside this circle. Ooh, that's a circle not centered at the origin. So I'm probably going to convert and make it a polar. This one is r equals 2. This one, so they're helping us by telling us that it's this circle. So we have a circle centered at the origin, which is 2. We have a circle centered at 0, 2, so it looks like this. We're in the first quadrant, and we're inside this circle, and outside this circle. So I should have drawn this better. I think it's saying this little region, this little sliver that we have. Yeah, inside that circle. Okay, so I should have drawn it a lot bigger. But anyways, I would like to convert. We've actually seen this a few times. It's easier to expand first and then convert, but then you get r squared minus r sine of theta is 0, so then you get r squared equals 4 r sine of theta, and you get r is 4 sine of theta. And that's that circle not centered at the origin. So that happened. All right, so yes, this happened, the circle not centered at the origin. What else we got here? So let's keep going. Set up a double integral of this one. So this is the other one I get asked about, I remember in previous years, because this one is not one of the ones I just said. So this seems like an extremely mean question. So at some point you're going to encounter this and be like, hold on, he lied to me. And I'll be like, I didn't write that exam. I didn't lie to you. Set up and evaluate a double integral to calculate the area between these two things. It doesn't say anything else. So what could we do if we were stuck? The fact that it doesn't say anything else makes me think we're integrating from 0 to 2 pi based off of the other examples we've seen. But we could plot points. So the strategy is, okay, I don't know what the graph looks like, but I know that if I plug in 0, I'm going to get these two different things. So let's label. So if I plug in 0, I get 6. And the other one, I get 3. Oh, that's interesting. I think I know which one's bigger. Ta-da! That was really all you had to see, was that 6 is bigger than 3. But if you kept plotting, let's say you plug in pi over 2, then you're going to get 8 and 5. So this is going to be 5. This is going to be 8. So the point of the question was, you really don't need to know what's happening in between here. You just need to know which one's on the outside. This is not the right picture I'm drawing. I'm just drawing kind of a blobby thing. But the key is that sine is between -1 and 1. And so there's never going to be any negatives. R is never going to be equal to 0. So whatever weird thing is happening, this is always on the outside, and this is always on the inside. And the question wanted the total area of all of this. So it's a double integral of 1 dA. So you had to realize that you really didn't need a picture that was accurate here to do this problem. You just had to realize you had to go all the way around, and this was smaller than the other. So yes, that sort of required a graph. That's beyond what I was saying, but you could do it without a graph, but you had to reason your way through it. That does probably make it a much tougher question, but that was the idea. Okay, I found this one on an old exam from some recent years where it said graph this, but it actually didn't say graph it. It gave 3 pictures. If they're giving you 3 pictures, you just need to plot the intercepts. Notice the intercepts here are very different. And so you would only need to plot a few points to know the answer. In fact, you could just plug in 0 and pi, and you probably would almost have your answer. So if you plug in 0, you get 5 minus 1, which is 4. Okay, they all seem to hit that. Plug in pi, you get -5. Cosine of 5 theta, so that's going to also be negative. So -1. And that means you get -4. So when you're looking this way, you should get a negative. So it's not this one. And it's not this one. So it's fairly quick to figure out that it can't be those others. All right. What else we got? Here's a question, but this one I give the equations, and notice we have a circle not centered at the origin. So yes, you need that r squared is 4r sine of theta. So you get r is 4 sine of theta, and you get r equals square root of 8. Okay, that wasn't so bad. Winter 2018, let's look at that. Use polar coordinates, find the volume of the solid below the cone, above the xy plane, and inside the cylinder. Okay, so it says below the cone. So I have 1/5. I'm solving for the z's. X squared. And sorry, my screenshot was a little blurry there. And then I'm going to draw the given xy equations. Okay, so I have this. Oh, what is that? Oh, I think that's a circle not centered at the origin. If I converted it to polar, I'm going to get this, and so I'm going to get r equals 10 sine of theta. Oh, that's one of these circles that's up here. You could plot some points to see it, or you could just complete the square and find out that's what it is. We're integrating over that. Now, I think there is an interesting thing to be said here. I believe this one, and I might be wrong. If you integrate from 0 to 2 pi, and you integrate from 0 to 10 sine of theta, and you do 1/5 r times r d theta, I think you might get the wrong answer. So that's a tricky thing about, that's the right idea. But the tricky thing about this one is if you plot a few points, so if you plug in 0, you get r is 0. If you plug in pi over 2, you get r is 10. So when you're looking this way, you're at 0. When you're looking up, you're here. And when you plug in pi, you're at 0. But I think that means you've already done a loop. So kind of hidden in this problem is a rows problem, which is we've already gone once around the whole thing when you get to pi. So I think this has to be pi. If you go around again, you'll be double counting. I think that's probably one of the trickier ones to figure that out. All right, I think that's enough. We'll end with that, but hopefully that gives you a feel for polar graphing.